Today's Tech Talk, DevOps Edition, is focused on instrumenting your microservices-based JavaScript application from start to end. Tech Talks are a series of short webinars that are deep dives for technical practitioners. I value your time today, and I'm excited to share with you these best practices so that you can leverage them in your daily role. I'm Jonathan Campos, a Senior Product Marketing Manager focused on observability, and I'm excited to be here with you on today's Tech Talk. Let's get started. For today's agenda, we'll briefly understand a little bit about observability. We'll understand the data behind observability. We'll have a quick discussion on what the difference is between manual and auto instrumentation, and then we'll go into our demo, how to make a JavaScript-based application observable with Splunk Observability Cloud. Now, when it comes to observability, we have to think that observability is a quality of the underlying app, IT services, and infrastructure. It gives us the capability to understand questions about how the system is behaving and not just whether the system is alive or not. With observability, we can start probing into why the application is behaving the way it is, get ideas for how the application may behave in the future, and answer questions that we may have never really thought of before. Observability's goal overall is to really answer the unknown of the unknowns. So you may already have existing monitoring and alerting tools. You may even have AI ops tools, but they were designed around a fundamentally different principle, which was you knew what you were looking for. With today's distributed applications that are built on highly dynamic infrastructure, microservices, and serverless functions that you may not even own and are constantly changing, you now need a much granular view into your environments, and that is observability. Observability provides a more granular visibility into the unexpected behavior of complex systems along with rich context. Good observability helps DevOps teams understand what is happening, take action, and provides rich, actionable insights to all stakeholders. Now let's go ahead and expand this slide here, and let's take a look at the data that's behind observability. Now when it comes to our complex deployments, while we're on our cloud-native journey to microservice architectures, we find that these classes of data to be most useful. Events, which identify that something's going on. Metrics, which answer, do we have a problem? Traces, to help identify where the problem is. And then logs, which identifies what's causing the problem. We sometimes don't have hours to fix issues, sometimes not even minutes. We want to make sure that we have all of the insight we need to make sure that our customer experience is never affected. So how can I make my JavaScript application observable with Splunk? We're going to take a look at that in our demo. But it really starts with an observability standard. Now, most of us know that Splunk Observability Cloud uses OpenTelemetry at its core. And OpenTelemetry gives you a single open standards-based set of instrumentation for your applications across all your data types, like metrics, traces, and logs. It also gives you more control over your data, since you no longer are locked down into any one vendor. You also have a better return on your investment, since you can instrument once and never really have to worry about it again. Now, when it comes to instrumenting your application, there are two ways that we can instrument an application: manual instrumentation and auto instrumentation. Manual instrumentation means that developers are required to change and add their application code to start and finish a span and define payloads by using the client libraries based on the development platform they're using for their applications. While manual instrumentation may help in better understanding what our applications are doing, what is concerning is what we forget and do not see. With automatic instrumentation, this requires no code changes at all. With auto instrumentation, we leverage an intelligent agent that attaches to the running application and extracts the tracing data for a quick way to begin gathering metrics. Now that we have a good understanding of what observability is and how we'll go ahead and collect our telemetry, which will be with OpenTelemetry, let's take a look at a walkthrough of how we can make a JavaScript-based application observable with Splunk Observability Cloud. We'll walk through how the application was built and then begin with Splunk infrastructure monitoring to understand our host metrics, then over to Splunk APM to see just how our microservices-based application is performing, and finally, Splunk RUM to get a good understanding how our users are doing with our application. Let's get started with the demo. This is a demo on showing how simple and easy it is to get your data in with JavaScript. So we have a JavaScript application, a microservices-based application that we're going to take a look at. We're going to configure it for Splunk infrastructure monitoring, Splunk APM, as well as Splunk RUM. It's a pretty simple process to really get going with a full stack observability cloud experience. And you're going to see it here today. So with that, let's first take a look at the code. So as I mentioned, we can auto-instrument applications and we can also manually instrument applications. In this case, what we did was manually instrument the application. You can see here on the top that we actually have emphasized the Splunk distribution of the OTel collector as a dependency here, and we've emphasized to start tracing with the service name dashboard microservice. So this is our manual instrumentation right here. And we've done that for the index, or what I like to call the main dashboard, the movies microservice, the actors microservice, and the directors microservice. Now, what is this application and what does it do? Well, this is a very simple application, and all it does is pretty much host movie, actor, as well as director information. Pretty much the main dashboard page can run a query to the movies microservice, directors microservice, as well as the actors microservice right here. And what it'll do is it'll give us a simple JSON output of the information that it's locally hosting here. So no databases, nothing too complicated, just a very simple setup that we have broken down here. Now, these bash files that you can see right here, or these bash scripts, all they do is just run a consistent query on the given microservice from the host that we'll be running the application from. And what we'll do is we'll go ahead and get the output. And you can see that actually running here in my terminal. You can see that, of course, the connection is refused. Things are just not looking good right now. And this is, of course, because the application is not running. So we're going to get the application started here in just a minute. We also have the error-prone microservice, which is the producer's microservice, which we actually do not have one. But we've put this here in place simply because we want to make sure that we can see some errors within Splunk APM. And then, of course, we also have here our main.html page where we'll actually paste our Splunk RUM code so that we can start to get data in and actually see exactly what's going on with our users. So with that said, let me also quickly show you my main.html page. And you can see here that what we'll do is we can click each one of these buttons. And of course, it's failing right now because, of course, the Node application is not running. But you can actually click these buttons here and we will see the JSON output of each one of these particular microservices, movies, actors, and directors. And it'll come out right here, that JSON output. So first things first, let's go ahead and go to our host, our server here, where I've actually copied over the code. And what I'm going to do is I'm going to run this particular bash script, and just really quick want to show you guys that, oops, let me clear the screen here just so that we have that. And what I want to do here is I am going to copy this here. I want to show you the output of, what we're doing here with respect to this bash script. All this is doing is starting the Node application. It's going to start the dashboard microservice, then the movies, actors, and directors microservice. So let's go ahead and do that now. We'll just go ahead here and we'll just say sudo bash, and our bash script will pump our password in, and that is up and running. So that's good to go. So to confirm that our application is in fact running, let's go back over to our main.html page and let's run a quick query for our movies, actors, as well as directors. Looks good. Those are directors, those are our actors, and here are our movies. So we're good to go there. So now we know our application's running. Let's make sure that our constant queries are running, and that also does look good. We can see all of the JSON output from our movies, actors, directors working just fine. And of course, our producers are failing because that microservice doesn't exist. But of course, we want to generate errors so we can see those on Splunk APM. So the first thing that we want to do when we want to get started with respect to our observability cloud implementation or our observability implementation with Splunk Observability Cloud is on the console here. We're going to go ahead and we're going to get started with infrastructure. So as you can see, we actually do not have any infrastructure metrics here. So we're going to go to our data setup page and we're going to go ahead and select Linux because of course we are running our Node application on Linux. So we'll go ahead and click add connection. We'll go ahead and use our default access token and we'll go ahead and click next. And then what we're prompted here is with an installer script. We'll go ahead and copy that installer script. And what this is going to do is this is going to install the Splunk OpenTelemetry collector. So we'll go back over to our server here. Let's go ahead and clear the screen so we have plenty of space to see what's going on. We'll paste that line of code. We'll go ahead and hit enter. And that's going to go ahead and download the necessary libraries that it needs to get this going. And once it's done unpacking here, you'll quickly see that the installation is complete. Let's go ahead and clear the screen here. And what we're going to go ahead and do is type service Splunk OTel collector status just to make sure that the actual service for the Splunk OpenTelemetry collector is in fact running. So that looks good. No issue there. Let's go ahead and clear the screen there. And let's go back over to our code. Now I want to re-emphasize something here. Our index dashboard, movies, actors, and directors have already been manually instrumented. And what we've done here is we've emphasized the requirement or the dependency to go ahead and then start tracing this particular microservice. We've emphasized the service name, as you can see here, directors microservice for the directors microservice. And the same for the actors microservice, movies microservice, as well as the dashboard. And you can see here on my package.json, I've emphasized the OpenTelemetry instrumentation library here, or dependency rather, as well as the Splunk OTel as a dependency, as you can see right here. So that allows us to take advantage of this particular implementation that we can see here. All right. So now what we're going to go ahead and do is we're going to go back to the Splunk Observability Cloud Management Console. We're going to go ahead and click Done. And we can quickly see that we actually do have some metrics coming in from our host. We can click on that. And just a quick browse, just to browse quickly, we can see our host name here. We can see our OS is Linux, how much memory and CPU we have available. And we can see some CPU metrics, our total memory, disk hops, so on and so forth. And this pre-built dashboard rather, is a great dashboard just to see exactly what's going on and get a good overview of this host. Now, you'll notice if we go back to our homepage, we already actually have some APM information coming in. And there was actually no configuration necessary. Why? Because we've already manually instrumented this application with the Splunk distribution of the OpenTelemetry collector, or the OpenTelemetry library rather. And the OpenTelemetry collector is already installed on our host here, and we've confirmed that. As you can see, it's actively running, no problem there. And it's actively collecting our traces. So that's great. So made that very, very simple. So we're already capturing infrastructure metrics. We're already capturing application performance information. So we're good there. The last thing that we need to do is set up our real-time user monitoring here. So that's very, very simple. We're going to get there in just a second. We've already viewed our infrastructure. We took a look and we can see that our one host is in fact sending data to the Splunk Observability Cloud console here. And we have all of those metrics. Let's take a look at our APM metrics, our application performance. Now, we can easily see here, and I'm going to break this down to the last 5 minutes, and we can easily see all of our microservices here. Quick overview of our red metrics and exactly what's going on, how many errors we have, what our latency looks like. Since everything's running locally, our latency looks really good. There's nothing crazy going on here. We have about 8 milliseconds here on our P99 for our dashboard microservice. Pretty much everything else is pretty much 1 millisecond. So we're looking good. One thing I want to highlight with respect to Splunk APM happens to be our dependency map. You can easily see here that if I select the dashboard microservice here, you can quickly see that we have a big red circle right here. And if we click on show legend, you can see that that's actually our error rate. And we're experiencing quite a bit of errors. Our other microservices look good, but what about this dependency map is so helpful is that it gives you a quick breakdown of the outbound dependencies and inbound dependencies for our microservices. Makes it really, really simple. You can break this down here under dependencies, and you can see, for an example, the dashboard microservice has 3 outbound dependencies. Of course, actors, directors, and movies. Pretty simple. And if we go ahead and we actually select the directors microservice, we can see that, of course, the directors microservice in this case happens to have an inbound dependency, which is, of course, our dashboard microservice. So pretty simple understanding of understanding your dependencies. And all of this is auto-generated. I did not do any magic to make this happen. Pretty simple. Pretty straightforward. And we can also see the latency that is occurring between each and every one of these microservices as, of course, these queries continue to occur. I want to also add that these queries that are running right here are running on my local machine. So there is a little bit of latency that, of course, we're going to see that 6 milliseconds here, 5 and 6 right here. The other thing I want to highlight is the tag spotlight. Now, Tag Spotlight is wonderful. Why? Because you get a great overview of what exactly is going on with respect to each and every one of your services. We can see that our actors microservice is in fact behaving great. All of our requests are looking good. We have no errors here. Let's switch this to our dashboard microservice, which we know in fact is having errors, or errors are occurring. Why? Because that producer's microservice is in fact not active. It's not running. And of course, we know it doesn't exist, but we want to do this for the purpose of the demo so you can see that we are in fact collecting some errors here. We'll hide the requests, we'll highlight, we'll kind of take a look at the only errors that are occurring. We can also see that from with respect to latency, with respect to that dashboard microservice, and get a good understanding of all of the latency that is occurring in between its outbound dependencies here. And we'll go here and let's take a look at the errors. Let's take a look at a point in time here. We'll just go ahead and select that point in time with all of these errors, and we can see that we are in fact running an HTTP GET request to a given endpoint. We know that that's the operation. We know the workflow that we're doing again is just a simple GET request. We're getting that JSON information. And what we want to go ahead and do now is kind of dig a little deeper. And I love this little plus sign here, this little plus symbol that we get here, because this in fact allows us to highlight a given point in time. We can click right here on the top of that, and we can see some example traces that in fact did highlight exactly what these errors were. And if we select one of these trace IDs here, we can clearly see that we're getting a 404 error. And what's it coming from? Well, yes, it's coming from the producer's microservice, which is in fact not found. So as expected, we are getting some errors here. So pretty simple, pretty straightforward. We can also see the span performance if we wanted to, just to get a good understanding of the latency with respect to this given trace. So again, just really high, just wanted to give you guys a high level some high-level information with respect to APM and how it's in fact showing our errors. Going back to the home screen here, we're going to go and set up RUM. Let's take a look at how exactly that's done. We'll go ahead and click on RUM first. And I want to show you that we in fact don't have any information here. And of course, the Splunk Observability Cloud Console is going to show us no RUM data found. So click here to get data in, GDI, get data in. We'll go ahead and click there, and we'll go to RUM instrumentation right over here, and we'll click on browser instrumentation. We'll click on add connection, and what this is going to allow us to do is select an access token, and we'll go ahead and click next. And once we do, we'll go ahead and give this an application name or an app name. We'll call this the movies dashboard. And it is in our lab environment, just to simplify things here. We'll go ahead and click next. And once we do that, we can see that we have a snippet that will add to the head section of every page that we want to monitor our application. So we'll go ahead and copy this snippet, and let's go over to our code again, and let's go to main.html. Now what I've done is conveniently emphasize exactly where we're going to paste that, which is of course within the head of the HTML. And this is just one simple page. We'll go ahead and paste that there. We'll save that HTML file. We'll go back over to our movies dashboard, which is in fact that main.html file. Let's run a couple GET requests here, and let's just get some activity going with respect to this page, so that RUM starts to gather metrics of our real-time, of our user. All right, so we've just generated some data here. All right, now we do in fact have some data. So again, it was that simple. Again, we can see that we have our application here. We have our source browser here from within the last 5 minutes. And we can see here, one of my favorite places to visit when I'm looking at RUM information happens to be the highest page load times. Now, we don't have a lot of pages to look at here, but we can definitely click on that one page that we were working with, which is that main.html, which happens to be this page right here. And we'll go ahead and click on that. And we can easily see a good breakdown of all of our information with respect to our users and our user. We'll have the environment, and this happens to be, by the way, the tag spotlight, the same tag spotlight breakdown or layout that we're used to with Splunk APM. We can see our environment, which happens to be lab, our application, what's happening, what URL we're actually querying, which of course happens to be my local machine, the URL type, as well as the browser that we're using, the browser version, the OS name, and so on and so forth. So this is just some great information to get some insight on latency of of our users. So if we see that, for an example, we're experiencing certain type of latency with respect to a given browser type or a given location, we can quickly then tackle it and identify just what's going on. So it's that simple, and we can of course highlight a given point in time and see exactly what's happened, see those metrics within that point in time. And we can also see some example sessions that have occurred and that duration time that occurred as well. So this is pretty good duration. I would say this is not too bad, but of course, if we see some high latency numbers, then it's something to be concerned about. So it's that simple to really get started with respect to a full stack observability cloud experience with JavaScript. Again, our code is pretty simple here. We have 3 simple microservices manually instrumented with the Splunk OTel libraries that we've emphasized as dependencies here. Thank you so much, and I hope you guys enjoyed this demo. Thank you. I really hope you enjoyed that demo. Why not give this a try yourself? Sign up for a free trial of Splunk Observability Cloud and grab a copy of this application from my GitHub repository. Be sure to copy this link here. There is great documentation detailing just how to do this yourself, or you can watch the demo on the on-demand video that will be sent after this live presentation. Thank you so much for attending today's Tech Talk. Before we wrap things up, I want to quickly share resources available to you to continue your journey with observability. You'll receive these assets in a follow-up email as well as the recording. Don't forget that we also have an incredible community of Splunk users on our community site. You can search for the answers section on Splunk Observability Cloud and continue the conversation for this Tech Talk within the discussion sections called Tech Talks. Here you will find additional resources to help you with your observability journey. We really appreciate you taking the time out of your schedules to join us today. Be sure to tune back in for future Tech Talks. Now let's open it up for Q&A.